So again, I'm Caitlin. I'm going to talk to you guys about civil engineering. Sorry. That's right. As long as I can just go through it. Yeah. That's fine. So this is just a little bit about myself. I graduated from UConn, the University of Connecticut, in 2011. I majored in civil engineering and I got a minor in environmental engineering. And I currently work at my first job that I got right out of college, Stan Tech Consulting Services. I've been there for 4 years next week. It's my 4-year anniversary, which is very exciting. And I'm currently a civil engineering designer, and I'm in the transportation and technically the urban infrastructure department. So we'll talk about what all that means in a second. There we go. So what is infrastructure? Usually I have these pop in so that you guys can try and answer, but you guys are lucky today and I just gave you the answers. So this is the wordy definition, and it's the physical components of interrelated systems providing commodities and services essential to enable, sustain, or enhance societal living conditions. And when I looked that up, I didn't even know what it meant, and I didn't even know that's what I was working on. So I broke it down a little bit more into something that's a little bit more understandable. So these are a list of different types of infrastructure. And I think you guys have heard of some of them, or most of them. So these are the different sections of infrastructure. We have transportation, water and waste management, communications, and energy. So types of transportation infrastructure are like roadways, railways, subways, airports, things that you guys use every day. And it helps you get from you or the commodity get from a place from point A to point B. That's what transportations do. Water and waste management help get the water from point A to point B. So this is drinking water, sewage collection, disposal, and drainage. And then communications, same idea. This is telephone, TV, radio. And then energy is our electrical power. So here is a typical section of what a New York City street looks like. Has anyone ever heard of what a section is, or have you seen something like this before? Okay. So a section is like, if you have a sandwich, right? Let's say it's turkey, lettuce, tomato, cheese on white bread. If you look at it from the top down, you're going to see just bread. You're not going to see any of the other stuff on the inside. That's what we call plan view. If you cut your sandwich in half and you open it up and you look from the side, you're going to see your white bread on top, then your lettuce, tomato, cheese, and turkey. That's section view, and that's what this is here. So the top layer up here is the street. That's the bread that I was just talking about. And everything underneath is the good parts of the sandwich. So in New York City, we don't have a lot of real estate. There's not a lot of room to put everything. So everything's just stacked on top of each other. And this is what I try and design to make everything work well together. So here we have the street on top. Then most areas of the city, you have the subway stations underneath. This area is the platform where you swipe your Metro card. And then underneath is where the trains actually are, so that's another level down. And if it's a big enough subway station, you might have another mezzanine level and then another subway station. And in between the station and the street level are all these utilities, all the different types of infrastructure that I was talking about. So this just points out a couple of them: electrical, steam, telecommunications, which is phone and internet, gas, sewer, water. This really large utility down here is the interceptor sewer, and that's what grabs all of the gross toilet water, yucky drain water, and that's all the way at the bottom.
Do you know anything about the hole in one of the
utilities?
Yeah, there's a hole in one of them that's like under the Hudson for like water transportation.
Luckily my company is not involved in that. I have not actually heard about that though. Is it leaking currently in the Hudson?
Yeah.
That's a problem. Well, that adds to what I was going to say next, is that the reason that the interceptor sewers are all the way at the bottom is because if there was a leak, you don't want it to infect and ruin basically all of your other infrastructure underneath. With water utilities, it's a little different because obviously if it leaks, everything contaminates what's above it as well. And I'm sure whoever designed that is now frantically trying to fix it. So these are, I'm going to go through just a couple of the different types of projects that I work on or that Stantec works on. And they follow all the different types of infrastructure that I mentioned in the beginning. So I said transportation was one of them, and an example of that was roadways. This is one of the projects that we're working on now. This is out a highway out in Long Island. And if anyone's ever been on Long Island, or most roadways, there's a lot of congestion. We live in a really populated area, and a lot of people drive, and people are complaining that there's traffic there always. So Stantec was hired to try and mitigate this traffic and come up with a solution to how to make the roads better and make traffic flow easier. So these orange areas, we start off by doing traffic studies. Sometimes you might see some people out on the roads with a clipboard, and they track every single time a pedestrian goes by or a car goes by. Now, today, that's how it used to be done, and people still do it for small projects, but today we use GPS, and I'm sure everyone in this room has a phone. Anytime, a lot of times traffic collectors use the GPS on your phone to track not where you specifically are going, but count how many people are going from point A to point B. So the first thing we do is traffic counts, and then we come up with solutions of how to make the roadways better. So these are just different types of additions that we added to this highway to make it flow easier. One of the things that I work on a lot is something called MPT, and that stands for Maintenance and Protection of Traffic. So any type of construction is going to involve a type of barrier or a work fence that's going to keep the public out and can keep the contractors and the work inside, so keep everyone safe. And again, because New York City is such a populated area, I don't think people would be too happy if you said, well, nobody can take the 4, 5, or 6 train for the next 6 months because we're working on it. That wouldn't work. Nobody would be able to get anywhere. There'd be a lot of angry people. So what we do is we try and set up diversions or plans, MPT plans, so that work can get done while pedestrians and cars and everyone can still get from place to place. This is, have you guys heard of the Barclay Center or Brooklyn Arena?
Yeah.
Has anyone ever been there? Have you noticed all the construction around it? It's going to be happening for many, many more years to come. But it's one of the projects that I've been working on actually since I started at Stantec. And currently they're putting a green roof on the arena, and they require these really, really big cranes to pick up these pieces of the green roof and place them on top of the roof. And again, the arena just opened up recently, and they didn't want to hear, well, you have to shut down for 6 months, you can't have any concerts, you can't make any money, because that's not what they want to hear. They said, figure out how to do it while keeping the arena open. So this was one of the areas where a crane was. This is Atlantic Avenue. It's like 3 or 4 lanes each direction. It's a really big road. There's one crane located here, one crane over here on this site, and one crane over here. And we had to figure out how to get the cranes up, installed, and then figure out how to keep pedestrians and cars moving around this area. So have you guys seen outside they're called concrete barriers, and they're about up to my hip high, and then they're usually painted white and orange, striped, and then there's usually a construction fence right above it, or those orange traffic cones or yellow sand barrels with a black top. That's all MPT, and an engineer designed where to put that. So this is just an aerial of the Atlantic Yards area today. So here's the arena, which does not have the green roof yet, but I think Google Earth is updating daily. It's about up to like here now. And right over here is the train yards. So the Long Island Railroad station is up here, and what the trains do is after they leave the station, they can either go out this way, or if they need to be serviced or held overnight, they're brought into this yard. So if you're standing on this sidewalk over here, you can look down into the yard. It's about 50 feet lower. And what our client, Forest City, is proposing to do is platform over these yards. And they're going to build about a dozen high-rises here. So this is the arena. This is just a cartoonish sketch, but this is the arena here. And once those those yards are platformed over, they're going to be putting all these high-rise areas. Have you guys heard of the Hudson Yards next to Madison Square Garden? They're doing the same thing over there. So it's happening in a lot of places now, again, because we don't have a lot of real estate, and they're thinking, how do we build on top of things that are already there? So this is the next part of the project that I'm currently working on. This is just a utility map of the arena area. So here's the arena, here's that Atlantic Avenue that I was talking about. And this is just to show you, it's a pretty confusing drawing. There's a lot going on. All these lines of all different colors signify a different utility. So gas, water, electricity, and so on. And it's my job as the engineer to take something like this and make sense of it. So before the arena was here, a lot of these utilities were not there because they didn't need to bring in the amounts of water or take out the amounts of water or electricity needed for a building of this size. So just to show you how crazy some of the utility sketches can be. And here are just a few pictures to show you what it looks like in real life, because on paper it's just a single line, but this is what's actually happening. So all of these areas were construction sites that Stantec was working on, and although on paper all the lines look to be straight and they're crossing and it just looks like they're all on top of each other, in reality they have to zigzag and go around each other so that they're not conflicting with one another. So here we have a gas line which is going up and over a sewer line. This water line is kind of jogging around. This gas line is all over the place. This one's pretty cool. You don't usually want to see this on a construction site. It's an electrical line that's been broken out of the casings. So with electric lines and telecommunication lines, they're all encased in like a PVC pipe, which is just a plastic pipe. And inside each of them you get up to tens of thousands of different lines. So in this case, I think the contractor accidentally broke into one of them and they fell out and now they look like spaghetti. Not good. Here's an example of a very large scale of telecommunication lines. This is down by the World Trade Center. This is Route 9A, or the West Side Highway. And these are all those telecommunication lines. So in each one of these little pipes is tens of thousands of those spaghetti-like structures that I was showing you before. This is, they're called river water cooling lines. And to give you, to show you how big they are, this guy standing here or here, they're probably about 6 feet tall. So these massive, massive pipes, I think they're 6 to 7 feet in diameter. So most people in this room could fit standing up inside one of these. And what they do is they take the water from the river, and instead of using electricity to cool all the mechanical rooms, this is used again down by the World Trade Center, we're using the already cool water to come in and cool off the machine, the mechanical rooms. So you know when you guys use like your laptop and it's sitting on your lap for a while, it gets pretty hot, right? And most laptops have fans to cool it down. But imagine then having an entire server room of computers, and then you have the generators and everything gets really hot. So instead of using an air conditioner, which you're going to have to pay for the electricity, this is what the World Trade Center is using. And this is, let's see if it'll work. Well, it's supposed to be a video of a 3D model. This is Columbia University. And so you guys are all in high school, right? Yeah. So by the time you guys get to college and then you go on to a career in engineering or whatever, regardless of what type of engineering you decide to go into, 3D modeling is the biggest thing, and maybe some of the students here can say that that's what you guys are working on now. When I was in college, we didn't, which wasn't that long ago, but it was all 2D stuff. I used AutoCAD a lot, and then I got to work and they said, 3D, it's the new thing, that's what you have to do now. And clients are requesting it because, like that utility drawing that I showed you before that just looked like a million lines on a piece of paper, the client can't understand that. It's too hard for them. They just want to see a clear picture, and 3D models is how we show the client what's going on. So that's kind of where the industry is heading. So if you're interested in becoming a civil engineer, these are just a couple of things that that I did or that I would suggest that you do. So you guys are all in high school now. I'm sure you're taking some math and science courses, but if you could take any extra, I think that's a good idea. Also, there's extracurricular activities like this program, or there's this program called ACE, which stands for Architecture, Construction, and Engineering. It's during the school year. It's an after-school program, and I can go into a little bit more about that later. I have some information about it. So once you go to college, you should probably pick a school that has an engineering program. Some people pick a specialty, like a focus or a minor. My minor ended up being environmental engineering. It's not because I enjoy environmental engineering, but I could have really gotten it in anything. I think it kind of just worked out that I ended up with a minor, to be honest. Again, extracurricular activities are great. They have things like Steel Bridge, Concrete Canoe, or the American Society of Civil Engineering are a couple of the ones that I participated in. And internships. Very important when you're in college. It gives you some real life experience before you actually get a job. It'll help you realize if you actually like doing what you're studying. And then once you get that job, there's a couple of licenses that you have to get, or you should get. EIT, or engineering training, that's currently what I am right now. You take an exam, it's a nice 8-hour-long exam after college, or you can take it your senior year. And it's basically tests you on everything you learned in college, from calculus all the way up to, for me, design of roadways. And there's different ones per type of engineering. So there's a civil engineering one, mechanical, electrical, and so on. And then after that, you can get 4 years of design experience underneath a PE, which stands for professional engineer. And after that, you get to apply to take your PE exam, which is another 8-hour exam. And because my 4 years is up, I'm lucky enough to be taking that exam soon. So, and then after that, once you pass your exam, you become a PE, and you basically get a stamp with your name and a number on it, and then you can sign off on drawings. It's just a lot more responsibility and a little bit higher to pay. So this is just a list of the different types of civil engineering careers you can go into after majoring in civil engineering. Civil is probably one of the broadest types of engineering. I think the other types of engineering are a lot more specific. But these are the different types. And maybe you guys should just call out if you don't know what some of these mean. So construction management, does everyone know what that means? Should I just explain it maybe? So construction managements, they're basically the, they're on the site, they make sure that everything's running smoothly. They're usually not a design person, but they're ones taking the design documents and making sure they're getting implemented out in the field. Geotechnical engineer, they're the engineers that deal with the dirt or the soil. Whenever you're building on something, you need to make sure that that something that you're building on is strong enough to withstand your skyscraper or your pavement roadway, whatever it is. You have to make sure that it's not going to sink, kind of like the Leaning Tower of Pisa. Water resources engineer, this can be either like water distribution, like bringing water from the site to the distribution system, or it could be purification, which is more on the environmental side. Structural engineers, we have structural engineers in the Stantec office. You can do either inspection of structures and make sure that they're not deteriorating or anything like that, or you can be designing things like bridges, skyscrapers, that's that nature. Surveyors, have you guys ever seen out on the roadways, there are guys who are usually wearing a vest and a hard hat, and they look like they're taking a picture, kind of like this tripod right here, but they're yellow. You guys ever seen that? And it looks like they're taking pictures of a bunch of things. So what that is it's taking measurements from a base point, and it's taking the measurements distance and elevation of curb heights, hydrants, building lines, anything in the area. And after the surveyors gather all that information, they're able to put it into a program like AutoCAD, and then I get those drawings, and then I can design off them. So that's like the first thing you do when you get a project. Transportation engineers, they're the ones that are doing the traffic counts or the pedestrian counts, like I explained before. And then coastal engineer, it's a little different, but they are actually under civil engineers. You specialize in designs that are on the coast, or you can also do underwater designs, like a bridge or retaining walls and stuff like that. And this has become a little bit more popular since things like Sandy have happened. So I feel like I just rambled for a really long time. I'm sure you guys have questions. Yep.
What is the environmental engineering called?
So for UConn, and I think most schools have, civil and environmental are very similar, probably until sophomore or junior year. You learn a lot of the same things in the beginning, but then when they split off and civil kind of goes towards roadway design or structural design, environmental goes off to more chemistry based. You learn about water purification or air pollution. Those are some of the classes I took. So that's kind of where it splits, but otherwise you're taking a lot of the same base classes. Mm-hmm.
Those 8-hour-long exams, is that for any type of engineering? Okay.
So it's if you want to become a professional engineer, and it's not all engineers get it. In my field, I'm pushed to get it, and I want to get it because I'm designing things. So I can design for 25 years, but I'm always going to have a PE on hand to stamp my drawings, or else they mean nothing. So that's why I'm going to get my PE. If I went straight into construction management, I wouldn't really be doing design work, I'd be implementing the design, so I might not need my PE. So it kind of just depends what and maybe some of you guys, I don't know if you've thought about your PE yet, but like mechanical, some get it, some don't. It kind of depends if you're in a design industry or not. I don't know what you guys else are studying, but does that answer your question?
Yeah, thanks.
Mm-hmm. Yep.
Could you talk a little bit about what your day-to-day looks like? Is it collaborative?
Definitely collaborative. It definitely depends on what part of a project we're in. So right from the beginning, there's a lot of meetings, a lot of collaboration with the architects, the client who's paying my bills and paying for the project, and then the design engineers, which I might not be the only engineer on a project. We might have an MEP, an electrical engineer, mechanical engineer. So everyone, we call it the design team. There's a lot of meetings to make sure that everyone's on the same page. We're given something, usually like a master plan, to say this is our main idea of what we want to accomplish at the end of this project. That's when we start to bring up things like, well, did you realize you have this underneath the area that you want to work, that you want to build something? Maybe that's not such a great idea. So in the beginning, it's a lot of collaboration, research, and stuff like that. Then once you get into the design phase, are you guys all familiar with AutoCAD, or you've heard of it? No. So it's just a computer program where I can create drawings like a lot of the ones that I was showing. So I use CAD every single day. Again, because I'm a design engineer, I use it every day. I'm usually taking my designs and then putting them into the computer so that we can print them and give them to the client. Collaboration never stops during the project, but it kind of backs off a little bit until you submit your designs, and then it starts up again. And then we get into the construction part, which is my favorite, and you get to go out with your drawings that you designed and make sure that everything's basically being built the right way.
You want a question? Yeah, no, sorry. So typically when you have a project, are you just going to work solely on that project from start to finish, or will you be working on multiple projects at the same time?
So my experience, I think, is a little unique, where I started on this mega project, I call it, because once the arena was built, they were like, okay, here, on to the next thing within that project. So now we're working on the development. But even so, even though I'm working on this mega project, I've had a lot of different shorter term projects. So I'm not only working on this. I've done a couple of other small projects, like 3 to 6 months, 6 months to a year, things like that. I think it's rare, especially in my office, to work on just one project. And if so, it's like very short term.
Guys okay?
Yeah. So you were talking about the electrical lines that were bundled in those PVC pipes, and like, you know, you showed us a picture of one that was shattered and the lines are going everywhere. How do you solve these problems, these like construction problems when they get in the way of a project or, you know, when they surface?
So that's why things like this, although it's scary and you hate to get those kind of phone calls sometimes, especially if it's a Monday morning, that's why I like the construction part of the project so much, because it's more fast-paced, you don't really know what to expect. So in this case, contractor, this actually wasn't my project, but I can imagine the contractor called up the design engineer and said, we didn't know this electrical line was here, we were just cutting open the ground and we hit it, it broke, can you please come out into the field now? And I really like doing site visits like that. You would never have to go design something like off the top of your head outside. A lot of times you go back to the office and design it, but just interacting with the contractor, making sure that they understand, okay, stop cutting the ground. And then in this case, the annoying part is that you have to make sure that you didn't sever any of the electrical lines and then basically rebundle it back together. But just in general, kind of like emergencies like that are kind of fun, as long as like no one's hurt. But they're kind of fun because then you get to go out in the field and it's more of a fast-paced job then. You get to get away from your desk for a little bit.
You managed to get much sleep.
I do, and I have a really good work-life balance. I think construction managers probably get way less sleep. They're on call a lot more. Other than during the construction phase, usually nobody has my phone number. During this time and when I know there's like night work going on, I can say, you know, you can give me a call. But other than that, I'm pretty much like 8 to 5, 8 to 6 on a normal, like 40 hours a week. It's pretty much what I work. So I do get all the sleep.
Oh, and like your company, we called them to help with like the Second Avenue line?
So we did, I know we had a part in it, we didn't win the project, but we would do something like that, yeah. We've done, we actually worked on the South Ferry, the one in our station down by the Staten Island Ferry, by like Bowen Green and Whitehall. My company designed that, so we did that entire extension and revamping of that station. And then when Sandy hit, we were able to, the station that's used down there now is the old one, because the new one got destroyed by Sandy and it's being redone as we speak. Yep.
Do you ever pursue any specific project, or it's always just given to you and you have to just...
So now that I've been with the company a little bit longer, I'm starting to get involved in the pursuit process. It's very rare that if I hear of something, like an opportunity, that my boss hasn't already heard of it. But I am starting to get into, like, I've been working on proposals and stuff like that, going to client meetings to say we deserve this job because of this. With the Atlantic Yards project, we've been working with this client for so long that we don't really do those type of meetings anymore. They just say, can you do this? Do you want to do this? Give us the paperwork. But in big projects like the Second Avenue line or something like that, my company would have to go and basically do a big presentation about why we deserve it and why we're better than the next guy. So.
What would make your company better than another company's?
Cost. That's what it all comes down to. But actually, a lot of times these departments want to see, or clients want to see, that you thought of something different. Innovative is the new word, sustainable, green, resilient, all those keywords that have been thrown around since, again, like Sandy happened. So you're given some information about a project. So